Okay, in this example, we would like to determine the magnitude of force F along the axis of OA and OB when force F perpendicular downward is 200 Newton. First of all, let's analyze it. If you assume force OA is along the beam OA like that, so I determine it FOA, what would be the direction of FOB? So if I assume it is downward, obviously these three forces, they cannot cancel out each other. These three forces are pulling this point O, and this point O will move to the right. So no worries if you take this direction, at the end you will get a negative value for your force number, but it is more logic if I consider the beam is pulling point O. Later I will explain in the next videos that what is the tension and what is the compression forces. So I have here FOB. Okay, perfect. If I want to draw the components of this vector, these vectors along the x and y axes, I need to draw my axis like that and determine the angles. So if you consider this is a right triangle here, as you can see this here, so this angle would be 30 because this angle is 60, and same if this is 45 degree, this would be 45 degree as well, correct? So you know, when you have two parallel lines, this angle is equals to this angle, and this angle is equals to this angle. They are opposite angles, and so on. So now FOA and FOB, let's write the equations. Sigma F along x-axis should be equals to 0, and sigma F along y-axis also has to be equal to 0 because the structure is not moving, we don't have acceleration, and it is in the at the static situation. So let's write the equations. For sigma of x equals to 0, I have FOA cosine 30. I explained in the previous videos why it is cosine, minus FOB cosine 45 degree, and there is no more horizontal component of any forces here, so equals to 0. Don't forget to put this sign here at the left. That determines that I'm considering right side is positive. Let's write the overall components along y-axis. If I consider upside positive, I have FOA sine 30. Again, you can watch the videos about finding the components in my channel. FOA sine 30, that is upward. Look at that, it is here. I'm talking about this, or actually this force. And similarly for FOB sine 45 minus F, because F is downward. But as I know what is the value of F, let's write its value, that is 200 newtons, equals to 0. Now you have two equations and two undefined, a system of equations that you easily can solve it. Let's plug the numbers. So I have FOA, this is what I'm looking for, and cosine 30, I calculated them before here, 0.86, you can plug it to calculator. Minus FOB cosine 45 is 0.7 equals to 0, and FOA times 0.5 sine 30, it is 0.5 plus FOB, this is again one of the undefined that I'm looking for, sine 45, that is 0.7, let's set equals to 200. I bring 200 to the other side. From the first equation, I can find the value of FOB. If I isolate it for FOB, it is equivalent to FOA 0.86 divided by 0.7. Even if you don't want to plug it to your calculator and find the value, no worries. Now it's time to substitute number 1 in equation number 2. Substitute 1 in 2. Okay, so FOA times 0.5 plus FOB, that is FOA, I'm taking from here, FOA 0.86 divided by 0.7 times 0.7. This 0.7 is coming from here, then equals to 200. I can simplify these two, and then I will have 0.5 plus 0.86, that is 1.36 FOA equals to 200, and from here you can find out that FOA is 200 over 1.36. This is time to 200, plug it to calculator, 1.36, that is giving you 147.05 Newton. This is the value for FOA, and by substituting number 1, equation, you can find FOB as well here. So FOB equals to FOA, that we just calculated it, 0.05 times 0.86 divided by 0.7. So this guy times 0.86 divided by 0.7, that gives me 180.67 Newton. And as we got two positive values for these components of forces along the beams OA and OB, it means, or the direction that we took is correct. I will solve more examples like this in upcoming slides. Please don't hesitate to write your comments, send your questions to my email, or write something in the comments for me.